Hi guys, we're doing optimization problems of calculus vectors. Every optimization problem has different types of examples. We'll be covering a few examples in this particular unit. There are different videos for each example. I recommend you to watch all the videos in order to go over every type of question. Let's move on to the first type of question. And this type is asking you to optimize volume. That means either you have to maximize or you have to minimize the volume. Let's read the question and let's see what the question wants us to do. A rectangular piece of cardboard that is 100 centimeter by 40 centimeter is going to be used to make a rectangular box with an open top by cutting congruent squares from the corners. Calculate the dimensions for the box with the largest volume. This means you are given a cardboard that is 100 centimeter by 40 centimeter. When you cut squares from the four corners of this cardboard is no longer going to remain a rectangle based cardboard. Basically, it is just going to be then left with this. When we fold this about this shape, we'll be able to turn this into a box. And this is how the box is going to look like. This box dimensions are going to be based on this cardboard's dimension because the cardboard's length was 100 and we cut x from each side. The length of the box is going to be 100 minus 2x. Similarly, the cardboard width was 40 and we cut x from each side. So width is going to be left with 40 minus 2x. And then this is going to be folded to make the height of the cardboard. So, and that dimension is nothing but x. Similarly, on each side we will be folding 4 sides, so we will have 4 x's, or basically it's going to give us a cardboard then. Sorry, box then. This is our first step of the algorithm and it's done. Let's go over the second step. Second step is to find out what do we have to optimize, and here clearly it says that we have to find the largest volume, so we have to optimize volume. So the equation also that we need is in terms of volume. Volume of a rectangle based prism, as the rectangular box is a rectangle based prism, is length times width times height. If we plug in all the values, length is 100 minus 2x, width is 40 minus 2x, and h is x. We expand this all. Finally, we will be left with an equation that's going to give us 100 minus 40x is 4000x. 100 minus 2 is negative 200x square. 2 times 4 is negative 80x square. Negative 2 times negative 2 is positive 4x cubed. I just simply arrange it in a polynomial equation form, and this is what I'm left with. Next is my third step, in which I want to find out my domain. Always remember, domain is the value of x that is going to limit this problem. And this problem you're going to limit what? Volume. And who's limiting your volume is your x value. Okay? Now to find out the minimum value of x and the maximum value of x, all we have to do is we have to see what could be the x minimum. Can we have any x value from negative infinity to 0? No, because dimension cannot be 0. X is nothing but height. If we have a negative height, we would not have this shape ever possible because the dimension of the shape cannot be 0. So the minimum x that we can have is definitely a 0. We cannot have it negative. Now what could be the maximum value of x? Like you see your maximum length that you see for this is not even 100. Okay. So definitely our x cannot be 100. Now it's something that can be subtracted from 100. But if I think something that can be subtracted from 100, From 100 you can subtract a lot of numbers, but not from 40 you can subtract all those numbers. So this is something that we're going to be using to find out our maximum value of x. Let's say if x is 20, 2 times 20 is 40, 40 minus 40 will be 0. So 20 is the value of x that can make this width 0. Alright, now what are we going to do is, if 20 is the value of x that is going to make this width 0, we cannot have anything greater than 20. So if I put this 25, 2 times 25 is 50 and 40 minus 50, I cannot do that. So I don't have to look on this side, I have to look at this side in order to decide what could be my maximum value of x. So from here I get to know my maximum value of x is 20. Once I do that, I move on to the fourth step. My fourth step is to now find out what is the largest volume. Largest volume means I am going to follow my extreme value theorem. And extreme value theorem you guys all know, or extreme value algorithm, everyone knows it because this is a requirement to do optimization problems. So this is something that you have to know before in order to do optimization problems. So extreme value theorem, the first step is to find out your derivative of equation. And in this case, our derivative is going to be that of volume. So volume derivative is going to be, because our volume equation is 4x cubed minus 280x squared plus 4000x. So this is going to be 12x squared minus 280 times 2 is 560x plus 4000. Our next step is to find critical numbers. Next step is to find out the critical numbers. So we are finding the critical numbers here. And how do we find critical numbers? We put the first derivative equal to 0. So if I put my first derivative equal to 0, I can clearly see my first derivative is nothing but a quadratic equation. And if I put it equal to 0, either I'm going to do quadratic formula or I'm going to use factoring. It's always better to use quadratic formula. This is my quadratic formula. Negative b plus minus root b square minus 4ac over 2a. Once I sub in everything in here, I would get 560 plus minus square root of 560 square, basically negative 560, minus 4, a is 12, and my c value is 4000, over 2 times 12, which is 24. So from here I'll be left with 560 plus minus. When I find this all under the square root, you can put this all on the calculator and you'll be able to see that you get 192,000 over 24. Here, when you take the square root of 192,000, you will be able to see that you get 438 as a square root. Now, when we put it on the calculator with a plus and a minus, we get two answers. One is going to be 5 and the other value is going to be 42. Okay? Since this is your critical number, so your x1 is 5 and 42 is your x2, it's your second critical number, we would see out of these two critical numbers which lie in the domain. And within my domain, 42 does not lie, so I'm going to cross this option out. My only x value that is left is 5. My next step is the sixth step. I am going to find out my volume when x is 0. So volume when x is 0 is 0. Next is volume when x is 20. Then also my volume is going to be 0. And next is I'm going to find out volume when x is 5. If I find my volume when x is 5, my value is going to be 13,500. Since this is going to be my largest possible volume, my dimensions for this box are going to be length is 100 minus 2 times 5, so it's going to be 100 minus 2 times 5, which is going to be 90. My width is going to be 40 minus 2 times 5, which is 30, and my height is x, so that is 5 itself. So my final dimension is length is 90 centimeter, width is 30 centimeter, and height is 11 centimeter. And here I get my final answer. And I'm done.